Hi there! Thank you for taking an interest in my topic. What's critical height sampling? How to do it? I'm Xiaoqi Luo, a graduate student here at UBC's Faculty of Forestry. My research focuses on critical height sampling, which I believe is a hidden gem in forestry that deserves more attention. In this video, I will introduce this fascinating method in a step-by-step tutorial on how to do it on your own. What's critical height? Before we dive into the details, let me quickly explain what critical height is. You must be curious, otherwise you won't have clicked on this video. The term comes from the specific height we measured on a tree when using critical height sampling. In simple terms, critical height is the vertical height from the ground to the point on the tree trunk where the diameter equals a specific critical diameter. Let's say it again, with some visual help. It's the vertical height from the ground to the point on the tree trunk where diameter equals a specific critical diameter. There are just 3 steps to measure it. First, determine the value of the critical diameter. Second, find the critical point on the trunk where this diameter occurs. 3, measure the height from the ground to that point. And that's it. Now you know what critical height is. So, what's critical height sampling? Simply put, it's a sampling method where we measure critical heights in the forest. A straightforward name for a straightforward concept. Perfect! What's sampling? Sampling what? So far, we've explained the first 2 words in the name. But what about the third? Sampling. Let me explain with an example. Imagine you are cooking borscht. It's packed with cabbage, tomatoes, and onions. Delicious. But how do you know the soup is tasty and ready to serve? You grab a spoon, scoop up a little, and taste it. That's sampling. You are using a small portion to get an idea of a larger whole. You sample the borscht with a spoon. I sample the forest with critical height sampling. Think of critical height sampling as the spoon, the tool, while the trees we select from the forest are like the spoonful of soup. Now, here's the question. Why do we take a sample of the forest? You sample the soup to check its taste. I sample the forest to estimate its volume. And by volume, I mean the volume of the tree trunks. Taking it a step further, I want to estimate the forest volume, the sum of the volumes of all the trees. But why is that important? Well, I have several good reasons. If you want to know how much carbon is stored in the forest, you need the volume. If you want to estimate how many houses can be built from the timber, you need the volume. If you are assessing how much fuel might be available in a wildfire, you need the volume. Conventional way to estimate forest volume. Here's the thing. We can't measure tree volume directly. Instead, we estimate it. Typically, after selecting a group of trees, we measure 2 key attributes. First is the diameter at breast height, or DBH. The diameter of the trunk measured 1.3 meters above the ground. Second, we measure the total height of the tree. Next, we input the DBH and tree height into a volume equation. Do some calculations, and that's it. We get the estimated volume of the tree. Sounds good, right? But here's the catch. Volume equations aren't universal. They are designed for specific groups of trees in a specific region, often under specific conditions, like age or the origin of seeds. It's like this. Imagine your parents hand you a uniform that was tailored for your older sibling. It might be too long, too short, too tight, or too loose. The fit isn't guaranteed. And it's the same with volume equations. You can't use an equation for western red cedar on a big leaf maple. So, what do we do? Luckily, we have critical height sampling. It's completely volume equation free. Fantastic, isn't it? How to do critical height sampling, a step-by-step tutorial. The process has 3 main sections: tree selection, measuring, and calculation. Step 1, tree selection. To explain this, let me take you into the woods. In simple terms, the tree selection process is all about comparing tree sizes. To do this, we use a device called an angle gauge. Here's how it works. The angle gauge is a small rectangular metal plate with 4 gaps of different widths, each labeled with a number. It also has a chain attached to the center, and at the end of the chain is a ring. The numbers represent the basal area factor, BAF, which I will explain later. In short, the larger the BAF, the wider the gap. For example, the gap labeled 4 is wider than the gap labeled 1. Now, let's assume I'm standing on a sample point. I hold the ring up to my eye with one hand, and with the other hand, I hold the angle gauge, pulling it away from my eye to keep the chain taut. Looking through one of the gaps, I align my sight line with the trunk of a tree at 1.3 meters above the ground. This is the height for DBH measurement. My eye, the gap, and the tree should all line up. Here's the key. If the DBH appears larger than the gap from my view, that tree is a sample tree. If the DBH appears smaller than the gap, it's not a sample tree. I repeat this process for every tree I can see from my position, spinning in the whole circle. After that, I know exactly which trees are my sample trees. Pretty simple, right? Step 2. Measuring. First, we measure the horizontal distance between the tree and myself, the observer, using a measuring tape. This is important because we need both the horizontal distance and the basal area factor to calculate the critical diameter at a critical point. It's a simple calculation that you can even do on your phone. Once we have the critical diameter, I use a Wheeler pentaprism caliper to locate the critical point on the tree. When I find it, I mark the point with a nearby spatial twig or a patch of moss on the tree for reference. Next, I use a clinometer to measure the side angle to both the critical height point and the tree base. With some basic triangle geometry and the horizontal distance, I can calculate the height. And there we have it, the critical height. Step 3. Calculation. After measuring the critical height of all the sample trees, we simply add up the critical height. Then, we multiply the sum by the basal area factor, BAF, that I used for tree selection. Now, let me explain what the basal area factor is. The basal area is the cross-sectional area of the tree trunk at breast height, 1.3 meters, which is the area of a circle with a diameter equals to the DBH. The basal area factor tells us how much the cross-sectional area of the tree trunk contributes per hectare. In forestry, we often use units like per hectare to compare values across different forests, no matter their sizes. So, the BAF essentially indicates how much the basal area of each sample tree contributes the total basal area of a forest, with units of square meter per hectare. Now, how do we choose the right basal area factor? The BAF should be one that allows you to sample the desired number of trees. Typically, this will fall within a range of 7 to 16. And that's it. We now have the forest volume estimate per hectare, and the best part is, we are free from the need for complex volume equations. Awesome, right? You are ready to conduct critical height sampling on your own. The next time you want to estimate the volume of a forest, you will have one more method to consider. Thank you so much for watching this video. I didn't have time to dive into my research findings here, but feel free to stop by my office at the Forest Science Building, 2201. I'd love to chat with you. See you again!